All right, greetings YouTube, beautiful mind here. Let's see. So no major announcements. This is going to be serve as a lecture for Wednesday of week 5 for applied statistics. I think we had exam 2 it was due this past Saturday. We can anticipate exam 3 to be due not this Saturday but next Saturday, going into week 6 or at the end of week 6. Let me see. As a quiz grade, it'll have a low weight, but it will count as part of your grade. So that should be available on Moodle. Also, make sure that you've completed the participation and honesty quiz. That's also on Moodle. Okay. I can't think of anything else, so I'm just going to move into the lecture for today. So we're going to continue chapter 5, moving into section 5.2, normal distributions and finding their probabilities. So, oh, that should say 5.2 objectives. So 5.2 objectives, how to find the probability for normally distributed variables using a table and using technology. Okay. If a random variable x is normally distributed, we could find the probability that x will fall in a given interval by calculating the area under the curve. Let me make sure. Yeah, this is fine. All right. So for instance, the probability that x is less than 600 is going to, if we use the chart with a mu of 500 and a standard deviation of 100, we will use a chart. The chart is going to tell us the area under the curve to the left of the x value. Okay. So consider a normal curve with an average of 500 and a standard deviation of 100 in upper right. Okay. So the value of x, one standard deviation above the mean, is going to be mu plus 500. I mean mu plus standard deviation. So 500 plus 100 is going to be 600, right? Now consider the standard normal curve in the lower right. The value of z, one standard deviation above the average, is mu plus sigma, which is going to be 0 plus 1 is 1. Okay. So the z-score of 1 corresponds to an x value of 600, and the areas are not changed with the transformation to a standard normal curve. The shaded areas at the right are equal. Okay. So the shaded area tells us the area of under the curve to the left, and that's going to be the probability that x is equal to that x value or z is equal to that z value. Okay. So let's look at an example. We have a national study found that college students with jobs worked an average of 22 hours a week. The standard deviation is 9 hours. A college student with a job is selected at random. Find the probability that the student works for less than 4 hours a week, assuming that the length of time college students work are normally distributed and represented by the variable x. Okay, so here, let me see, an average of 22 hours. So our mu is 22 hours, and our standard deviation is 9 hours. All right. Find the probability the student works less than 4 hours. So let's change this to a z-score. The z-score should be equal to x minus mu divided by sigma. In this case, if we want the probability, it says find the probability the student worked less than 4. We want the probability that x is less than 4. So we're going to say 4 minus 22 divided by 9. What is that? Negative 18. So that's going to be negative 2. So the z-score is going to be negative 2, right? So then with z being negative 2, we would look at our chart that's in the back of the book and read the chart. So again, we have a z-score of negative 2. So then we would go to our chart. This is standard normal table, shows that the probability z is less than negative 2. So this 0.0228 comes from a table. Okay. And then that's it. The chart tells us the area under the curve to the left of our z-score. All right. So then that's the probability that x is less than 4. Okay. All right. Let me see. A survey indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed and represented by the variable x. A shopper enters a store. Find the probability that the shopper will be in the store for each interval of time listed below. And then when 200 shoppers enter the store, how many shoppers would you expect to be in the store? Okay, let me see. A survey indicates that for each trip to a supermarket, a shopper spends an average, so that means our mu is 43 minutes with a standard deviation of 12 minutes. The length of time, blah, 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 blah. Okay, so for part A, for number one. So they're asking for the probability that x is between 22 and 52 minutes, right? So we will find the z-scores associated with these. So the first z-score would be 22 minus 43 divided by 12. We get an answer. And then the second z-score is going to be 52 minus 43 divided by 12. We get those answers. Then we look at the chart, we get the probabilities, and we subtract the probability. So if we want the probability of x being between these two values, once we convert it to a z-score, we look at our chart, we get our probabilities for each one, we subtract, okay? So you see that there, we get a negative 1.75 for the first one and 0.75 for the second one. So if we subtract those two, those are the z-scores. We got to look at the chart to convert the z-scores to the probabilities, subtract our probabilities, and we get a probability of 0.33. So then if we had 200, the second part of the question asks, if we had 200 people enter, what's the probability they're going to spend anywhere from 22 to 52 minutes? So we would say the 0.7333 times 200 to get our answer, which is approximately, we would expect 147 shoppers to be in the store during that range. So then the next one, let's see, question 2 asked, what's the probability that they're more than 37 minutes? So again, we're going to convert the x value to a z-score, find the probability. Now, since we want more than 37, remember the chart tells us less than 37 or less than the x value. But if we want more, we got to use the complement rule. So we got to say 1 minus whatever probability we find there. Okay. So we converted it to a z-score, use the chart to find the probability, and then we're going to say 1 minus that probability to get more than, and we get about 70%. And then the probability that if 200 shoppers enter, that is that they spend more than 37 minutes, we're going to say 70% of 200 is what? About 140? 138 shoppers would be in there for more than 37 minutes. Okay. Let me see what else. How much time? We've only been on here for 10 minutes. I'm going to have to take a break and come back, guys. I'm not feeling too hot. Let me see. So in this example, we have that triglycerides are a type of fat in the bloodstream. The average triglyceride level for U.S. adults age 20 and older is 97 milligrams per deciliter. Assume the triglyceride levels of U.S. adults who are at least 20 years old are normally distributed with a standard deviation of 25 milligrams per deciliter. We randomly select a U.S. adult who is at least 20 years old. What's the probability that the person's triglyceride level is less than 100? So we're looking for the probability that x is less than 100, right? So because it's normally distributed, we had an average. The average is 97 milligrams per deciliter, and a standard deviation 25. It says, what is the probability the person's triglyceride level is less than 100? Yeah, right? So same thing, right? Convert this x value to a z-score. Use the z-score to find the probability, and then that probability is going to be the answer. Oh, and then we can actually use technology. So these are actually functions in the TI-84 Plus. Like if you have that calculator, you could do normal CDF, and then but you would do the minus 10,000. I think that's like the far left, or how many? I forget what the minus 10,000 is. But then the 100 is our x value. I think the 97 was the average, and the 25 was the standard deviation. Okay, you can actually use technology. I know that we've only been here. Let me go ahead and try to do one more. Okay. All right, let's let that be. Let's do one more. All right, and we are back. Okay, so let's take some time to go through, continue chapter 5, and we'll go ahead and do section 5.3, normal distributions, and we want to see finding the values. So in the last section, we were given x values and we found the probabilities. Now in this section, we're going to be given probabilities and work backwards and find the values. Okay. All right. So how to find a z-score given the area under a curve. So given the probability, how do we find the corresponding z-score? How to transform a z-score into an x value. And then how to find a specific data value of a normal distribution given the probability. So in the previous section, we were given a normally distributed random variable x, and we were asked to find the probability. So we took the x, converted it to a z-score, and then from a z-score to the probability. In this section, we're going to be given the probability, work backwards, convert it to a z-score, and then change the z-score back into our variable x. Okay. So we want to find a z-score that corresponds to a cumulative area of 0.3632. So then we would look at the chart, and on the chart we would have to find, let me see, I think we got one here. Right here. You see the 3632? So this is the chart that's in the back of the standard normal table in the back of our text. So we found the 3632, so the z-score that corresponds to that is negative 3.5. So that the corresponding z-score is a negative 3.5. Sorry, negative 0.35. Told you I don't feel well. Anyway, let's do the next. Find the z-score that has a 10.75% of the distribution's area to the right. So we have to convert that percent to a decimal. That's going to be 0.1075. We have to look at the chart. If that's to the right, the chart gives us the area to the left, right? So if the area to the right is 0.1075, that means if we want to find this on the chart, we have to say 1 minus that. So it should be like 0.8925, right? So 1 minus, we got 0.8925. We're going to look on, now we go to our standard normal table. You see the 0.8925, and the z-score corresponding to it is 1.24. Okay. All right. Find the z-score that corresponds to each percentile. So if we're in the 5th percentile, that's like 5%. So then that's going to be 0.05 on the chart. 0.05 on the chart. All right. Okay. So the area closest to 0.05 in the table is going to be the 0.0495, and that corresponds to a z-score of negative 1.65. And we got this 0.0505, which is negative 1.64. So because the 0.05 is halfway between these two, we're going to take the 0.645, 1.645, negative 1.645. All right, let's go to the next one. Okay. So 50th percentile, that's right smack in the middle. That's 50%, 0.5. So the area under the curve should be, what, 50%? Z-score, what z-score corresponds to 50? 0, right? Yeah, 0. Because it's right in the middle. Even if you go to the chart, it should still give you 0. Once you find the 0.5 as a percentile, then you look on the sides and the z-score is going to be 0. 90%. So again, you would just look at the chart. Let me see if we don't have one here. Okay. So it says if you locate the 90% under the standard normal table, the area closest to 90% is the 0.8997. So the z-score that corresponds to that is going to be about 1.28. So the chart doesn't have exactly 0.9, so we get the closest one there. Okay. And we can actually use Excel to kind of work backwards. So to transform a z-score to a data value, I pretty much just plug it into the original formula and use algebra to work backwards. So I think in the last section, we made a statement that so to convert an x to a z-score, sorry, it's clear the ink. So to convert x to z-score, the z-score is going to be x minus mu divided by sigma, all right? So then you can actually just use algebra here. 1.96 equals x minus, what's our average here? X minus 9 divided by 2, right? So then ultimately, x is going to be 2 times 1.96 plus 9, which is the formula that you just saw. And we're going to pretty much do that for each one. Okay. I'm going to let that be. So in this example, we have scores for the California Peace Officer Standards and Training Tests are normally distributed with an average of 50 and a standard deviation of 10. An agency will only hire applicants with scores in the top 10%. What's the lowest score we can earn and still be eligible to be hired? So if you're in the top 10%, that means you did better than 90%. So then the percentile is 90. So we would look for 0.9. I think we literally just did that one, right? Let me think about it. So we have the percentile. It's 90%. So then we will work backwards to find that z-score. I think we just did that one. Was the 1.28, right? I think it's the 1.28 from the chart. All right. We have our z-score. Then once we have our z-score, we can work backwards to find the x value. All right. When we get this. So that means you have to score at least about a 63%. Okay. And we can use technology to find these as well. Okay. In a randomly selected sample of women aged 20 to 34, the average total cholesterol level is 179 milligrams per deciliter with a standard deviation of 38.9 milligrams per deciliter. Assume the total cholesterol levels are normally distributed. Find the highest total cholesterol level a woman in this age group can have and still be in the bottom 1%. Okay, so if that's the percentile, right? So we work backwards, right? Find the z-score associated with that. Looks like it's a negative 2.33. Convert that z-score to an x value. And we'll get this, okay? You can also use technology to find these, okay? So I'm available, like if any of that is not clear or if we need to kind of like go back and forth, we can talk about any of this. I'll go ahead and make sure that some assignments are loaded correspond to this. I'll also try, if the quiz is not already up, I'll go ahead and try to get a quiz going as well. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.